to look at now we want to look at some of these worksheet problems that you have. Okay, so and what you're going to be keeping in mind is that you're going to be doing factoring. They're going to go quadratic. Okay, you're going to be using identities to simplify things, um, and uh, and so that's what you're going to find with these. Okay, so let's take a look at a few of them. Okay, let's start here with this number 2. Okay, the last thing you want to do is make the mistake of saying, let me divide both sides by sign. That would be a terrible thing to do because you would eliminate one of the solutions. Okay, because this is effectively quadratic. Some people will choose just to make that, let's just say u squared is equal to u. I told you before, you don't do this. Don't divide both sides by u because that loses a solution. What you do is you say sine squared of x minus sine of x equals 0, and then you pull out the common factor of sine of x, and you notice that is sine of x, okay, minus 1 is equal to 0. Now, you have the product of two things. You have a times b is equal to 0, which means a is equal to 0 and b is equal to 0. So you say, well, the sine of x is equal to 0, and we want to find where all occasions where that happens. And you also have the sine of x minus 1 equals 0, or effectively the sine of x equaling 1. Now, as you know, the sine graph will kind of say it all for you. There's your sine graph. It hits 0 at 0, pi, and 2 pi, but it really hits at all multiples of pi. So we could just say x equals pi k, which covers all the times that this happens. And then where is it equal to 1? Well, that's pi over 2, and then a whole wavelength down the line. So it's at x equaling pi over 2 plus every wavelength 2 pi k down the line. Okay, so this covers all the times, all the solutions to this equation. Okay, take a look at a couple more. I think you'll attack number 2, number 4 the same way. Number 1, I would send cosine over divide by it and turn it into the tangent. Something to think about. Okay, so now we get into things that are factorable. Yeah, let's do cosine over here. So here we have 2 cosine squared of x plus cosine of x minus 1 equals 0. Well, that's really no different than 2u squared plus u minus 1 equals 0, which is asking you, pleading with you to factor it, right? Factor it. Factor it. So how does it factor? How does it factor? Okay, so to factor that, we can obviously see that we're probably going to go with a 2 cosine and a cosine, okay? And then we have probably a plus 1 and a minus 1 here, right? Let's just check to see that that works. So this is negative 1 cosine, this is positive 2, giving me a positive 1 cosine. This is equal to 0, which the two factors are each equal to 0, which says 2 cosine minus 1 equals 0, which says the cosine of x equals 1/2, okay? And the cosine of x equals negative 1. And again, our graph of the cosine will in many ways help to illustrate how we find that. Where does the cosine equaling negative 1/2? Well, a negative 1 rather. That's at pi, all right? That's at pi where cosine, so x is equal to pi, but then all wavelengths down the line make it plus 2 pi k, right? Okay. Now, where does cosine equaling 1/2? Well, in the first and the fourth quadrant, okay, 1/2, okay, is the pi over 3 reference, right? So x will equal pi over 3, which will count for this guy and every wavelength down the line plus 2 pi k. And then this guy in the fourth quadrant, which is a reference of pi over 3 in the fourth quadrant, which is 5 pi over 3. So x equals 5 pi over 3 plus all 2 pi k values down the line. Okay, so that would be the 3 sets of solutions to this equation, which was, well, it's quasi-quadratic. It's factorable over a quadratic. Let's take a look at another problem or two. recognize that 7 is going to be another factorable quadratic. 8 we'll defer, as I said. We'll come back to that. Another factorable quadratic in 9 and 10. It's factorable. Well, no, actually 10. Let's look at. The red flag should come up in number 10 because it's mixed functions, sines and cosines. Okay, so that is saying to you we got to do something about that. Okay, that is not something we can just factor right away because it's effectively two different functions. But here's where we pull in our identities. Okay, we know that the cosine squared can be re-expressed in terms of the sine squared. Okay. So that being the case is probably the first order of business. So I'm going to take care of that. I'm going to replace the cosine squared with 1 minus the sine squared. That's using our identities there, okay? Plus the rest of it will come down. Root 3 sine of x, okay, minus 2 equals 0. Now I distribute and I say 2 minus 2 sine squared, okay, plus root 3 sine of x minus 2 equals 0. Well, it looks like my 2 and my negative 2 will be lost, so that's fine. So I get, it comes down to negative 2 sine squared of x plus root 3 sine of x is equal to 0. So that's fine. I got a common factor of sine. I'm going to pull out my sine as a common factor, and then that's going to factor over minus 2 sine, okay, plus root 3. All right, and that's equal to 0. So here now I got the product of my two factors equaling 0. So that means each one of them is going to equal 0. So I have the sine of x equaling 0, which of course we said previously is at all values of pi k. And here I'm going to have this expression equal to 0, or better yet, the sine of x is going to equal negative root 3 over negative 2. So then the sine of x is equaling positive root 3 over 2, which should be a familiar value referenced at pi over 3. So x is equal to pi over 3, and also 2 pi over 3 because of the second quadrant being positive as well. So it's pi over 3 plus 2 pi k, and 2 pi over 3 plus 2 pi k. Okay, so that's our sets of solutions for that equation. All right, let's see if we can find a couple more interesting problems of sort. Okay, this guy's going to be factorable. Okay, it looks a little intimidating at first, but this is a factor by grouping. Split it down the middle. Take out the tan. Take out the tan of x, and then you get 2 sine of x plus 1 minus, pull out a 1, and then you get 2 sine of x minus plus 1. So that should be, you should be able to reckon with that from there, okay? Let's see. Okay. These I said we're going to defer. Okay, we're going to defer these here with the period adjustments. We're going to defer until a future reference. Okay, so let's do one more, and let's take a look here at number 20. That looks like it might be fun, huh? Okay, so in number 20, I got mixed functions, sines and cosines, which isn't gonna bode well for me. So I have to put one in terms of the other. So I have an option. I could either name I'm going to elect to go with sine. So in other words, this cosine to the fourth, I'm going to rewrite as the cosine squared of x squared. But then the cosine squared is 1 minus the sine squared of x, and then that's going to be squared. So let's see. We have a 2 out in front. I'm tempted to want to divide through by that, but I'm going to defer that for the time being. as they say, cosine of fourth is going to be rewritten as 1 minus the sine squared of x squared plus 1 minus the sine to the fourth power of x equaling 3. Now I got to expand this out as a trinomial. 2, that's 1 minus trinomial, because it's like a minus b quantity squared, so it's 1 minus what? 2 sine squared of x plus sine to the fourth of x plus 1 minus the sine of fourth. Okay, equals 3. Looks like I got a couple things that can do a little disappearing act here, right? Okay, so let's see what's going to happen here. Okay, good. I'm going to lose this sine to the fourth term. Okay, and okay, so we're back here. We're going to collect our terms together. We got a 2 riding on the outside here. I got 1 plus 1, that's 2. We saw that we canceled out the sine to the fourth. 2 minus 2 sine squared is equal to 3. So now I'm going to distribute. I'm going to get 4 minus 4 sine squared of x equaling 3. I subtract 4. I'm going to run out of space here. Okay, so I subtract 4, which is going to give me negative 4 sine squared of x equals negative 1. So that means that the sine squared of x is going to equal, what, 1/4? So that means the sine of x is going to equal plus or minus a half, which is what? All pi over 6 reference angles? All pi over 6 reference angles. So I have pi over 6 plus 2 pi k. I have 5 pi over 6 plus 2 pi k. I have 7 pi over 6, 7 pi over 6 plus 2 pi k. And I have 11 pi over 6 plus 2 pi k. Now there's a way of condensing these in terms of pi, because if I take that first hit, so you know, it's fine. I don't mind if you leave them at that, but realize you could also say, well, pi over 6 plus pi k will get me the 7 pi over 6, so that covers that. You know, those two are kind of condensed into there. And then the second strike, the 5 pi over 6 plus pi k, you know, for pi, k equaling 1 would be 6 over 6. That would give me this 11 pi over 6. So this is a more condensed form of that answer. And there you have it. Some of those problems that might have been, you think, in your worst nightmare, they actually worked out. So, okay. So I hope you enjoy those problems, work them out, and have some fun with them. We'll do more in class tomorrow, and you'll see them on the